We're talking about California state symbols today, right? So what I want to know from you is if you have any California knowledge beyond rocks, gems, and minerals. So we're going to start a little easy today. And you all in the comments, if you know the answers, maybe before Gavin and Graham do, you can get to writing. What do you think California's state bird is?
Graham, you're the bird guy.
I am. I don't know. I would like to say it's the California quail, which is one of my all-time favorite birds.
Well, that's a good guess. Yeah, that actually makes me reconsider my guess. I was going to say the condor, the California condor, but I don't know.
Wow, that's a good choice. But Graham, you're right there with it. It is the California quail, and we should note too that y'all aren't from here. For those of you who don't remember, we got a Wisconsinner and a Long Islander here with us today. So this is going to be challenging for them, but it's a good opportunity for everyone watching to show what you got. All right, so California state bird, the California quail. All right, what about the tree, California state tree?
It's one of two, right? It's got to either be the sequoia or the redwood. One of those is my guess. Graham, you got another one?
I was gonna guess the redwood.
But also Joshua trees are iconic. Man, now there are so many good trees. I don't know.
Wow. That's also a really good point. Gavin, you're good at coming up with the runner-ups, I think. But the answer for California state tree is indeed the redwood.
Redwood.
All right, let's go to amphibian.
Huh.
Goodness.
Amphibian.
This one we talk about in Santa Cruz. It does live here in Santa Cruz, but it's endangered.
It's not a salamander, is it?
Nope. Salamanders are great, but nope.
Yeah, my guess was going to be a salamander too, so I've already struck out.
What is it? I don't know.
Yeah, no clue.
The red-legged frog.
Oh, cool.
Yep. All right, let's see what else we got here. Okay, we're going to get into some different kinds of stuff. Oftentimes we use state symbols as parts of industry, not just natural things. And so what about the state vegetable?
State vegetable.
I want to say kale, but I'm just kidding.
Kale's a good one. The state vegetable.
It's kind of like a funky looking flower.
Oh, is it an artichoke?
The artichoke.
Yeah. So we got the artichoke really good. Now, the state fruit is kind of along your joke that you were making, Gavin, about the state vegetable. So if you wanted kale to be the state vegetable, what do you think the state fruit might be?
Is an avocado a fruit?
It's a drupe. I don't know if that is technically a fruit, but California decided that it was.
Awesome.
All right, let's just do a few more. What about the state sport?
The state sport?
Sport.
My goodness.
I feel like this was a newer one that I remember hearing about in the news maybe not too long ago, not too many years ago.
I mean, we live in Santa Cruz. My first guess is surfing. Could it be surfing?
It is indeed surfing. Let's jump to one that's a little bit kind of in your guys' world, just because of one of the people who I know you work with, Dr. Hildy Schwartz. She gave a talk where she focused heavily on this one. Do you guys know the California state dinosaur?
Oh man.
Oh goodness. I know it, but I don't remember it. I've looked at a poster with this dinosaur on it so many times.
I don't know.
I can see a picture of it in my head, but I don't have the name for it.
Yeah, and this one, it's an herbivore, and it's found, I believe, like only in Fresno. So one of the things that we often also think of when we pick like a state symbol is if it's like unique to that area. So this one it's only been found, the fossil remains have only been found here, and it's called Augustinolophus. I know I said that wrong, but that's it. And we're going to end with one that's close to the museum's heart. Do you guys know the state marine mammal?
Ooh, is it a whale? And
There's a whale.
the whale that is in front of the museum, the title of which is slipping my mind now. Is
It
that
is
a right whale?
indeed. So one of our nicknames in the community is the Whale Museum. We've got a cement whale outside, and that is a gray whale, a California gray whale, which is also the marine mammal for the state. So well done, gents, for not being from California. I think y'all did great. And without further ado, why don't you fill us in on a couple other state symbols?
Sounds great. Okay, I'm going to share my screen here. And I'll make it full screen. So, as you mentioned, Marisa, we're going to be talking about some state symbols today. We'll have the state rock, the state gem, and the state mineral. And Graham, this is just a beautiful lineup of specimens, isn't it?
This really is. I cannot wait to dive in. And I think we'll sort of we'll get increasingly shiny as we go through. But even our intro is going to have plenty of gloss to it for us to enjoy some illustrious California geology.
Well, Graham, I think that we should start with maybe the most popular rock that folks have brought the gents to look at over the past couple of years, and that is serpentinite. We've talked about it before. It's iconic when it comes to California. You could just walk along and pick up a piece of it, which is just so cool. So, Graham, tell us a little bit about the looks, the textures, what makes serpentinite serpentinite.
Oh my gosh, fantastic. So, first and foremost, a little bit of vocabulary. This is a pickle we often find ourselves in at the pop-up. Serpentinite versus serpentine. So serpentine is the green mineral that makes up most of serpentinite. And so we often sort of get lazy and say serpentine or serpentinite, but serpentine is a mineral, and the mineral, when you have a bunch of it making up one rock, we call that rock serpentinite. And so serpentinite is going to take a lot of those properties of serpentine and sort of showcase those. So it's usually a bright green color. It goes from dull green to bright green, but often pretty green, sometimes a little gray, sometimes a little blue, but always sticking to that green color. It can have what we call a resinous or dull luster. So it often kind of has like the luster of like what plastic or resin out of a tree might look like. And so it's kind of got kind of this soft, pearly to dull luster. It often has sort of sheety things, or sometimes they look sort of like filaments. That's because serpentine is in the amphibole family, and so it's got these long or it's related to amphiboles, so it's got these long sort of sheety to filamentous little crystals to it. And then, Gavin, there's something really special that we see in the rock serpentinite, and that is those sort of lightning bolt white streaks. What are those?
Well, Graham, these streaks are called veins. And those veins are a little bit of a clue as to how serpentinite is forming. And so serpentinite is really distinctive of California because California is a perfect place to make it. And that's because you have a subduction zone. We've talked about that before, where you have really dense oceanic crust running into less dense continental crust, and then it actually subducts below it. And the rocks that make up the ocean crust, mostly basalt, get pumped with this really salty, really hot water. And over time, a metamorphism happens. And so serpentinite is actually a metamorphic rock. And it is when basalt is metamorphosed in subduction zones. And Graham, we said it's from subduction zones, but we're finding it on the surface. So what's up with that?
Oh, such a good question, Gavin. A classic geologic conundrum. When we've got these rocks that form deep underground, how do we get them up to the surface? And so there's a couple things going on here in California that are bringing these rocks up to the surface. First thing is uplift. There's, as the ocean crust is, subducting. There's a lot going on tectonically that's driving the landscape upward. Add onto that a very active network of faults. Those faults help move those rocks up. And so this uplift is, combined with this faulting, and that helps to bring rocks from deep underground up to the surface. So we've got all these processes that have serpentinization going on in the ocean crust, and as the crust is subducting, and then this faulting and uplift that's bringing it up to the surface from deep underground.
Interesting, Graham. Okay, and so we said that it's the California state rock, but is it just found in California?
No. So serpentinite is found in California abundantly, but that's because California has this ocean continent subduction zone. So because you're having, this is going on in California, you can actually be making serpentinite anywhere that you're driving ocean crust underneath the continent. And you can be bringing that serpentinite up to the surface in any of those locations too. So we see serpentinite forming all around the coasts of the world, as well as former coasts of the world. There's no ocean in the Ural Mountains of Russia or in the high Tibetan Plateau, but those are all these closed subduction zones, and so we actually see serpentinite in some of those places.
That's interesting, Graham. And so if I were to go to the Ural Mountains and pick up a chunk of serpentinite, would it look like the serpentinite that we have in California?
No, gee, and that's such a good point to bring that up, because the serpentinite in a lot of these places, it's old, it's relict, it's from a long time ago, so it's not very common. Serpentinite weathers really easily. So serpentinite likes being deep underground in hot, salty water. It does not like being up in the air, exposed to the elements and the rain and wind. And so serpentinite on the surface gets broken down really readily. So one of the ways that California is really special is because it's such a geologically active area, it keeps bringing up this conveyor belt of serpentinite and keeps bringing up a lot of fresh serpentinite to the surface.
And Graham, what does all of that weathered serpentinite do? Because as you said, you weather serpentinite out, and I think the biologists in the room will have something to say about this too, because you get serpentinite soils, and there are actually plants that only grow with serpentinite soil. So it's kind of cool because it's not only a really iconic rock of this place, but it also shapes the landscape so much because of how just doggone good California is at making serpentinite.
That's so true. And one of the things that's really neat about California from a biologic standpoint is how many, really local types of critters there are. There's plants and animals that can only be found in California. And in terms of some of those plants, a lot of them, it's because they are specially suited to surviving on serpentinite soils. And there's all sorts of, cool ways that, this is just one of those cool ways that geology can really affect how life can survive in an area.
Oh, man. All right. Well, I don't know how we can follow up serpentinite. It's just such a cool rock. But honestly, the state gem is also really, really interesting looking. And so let's take a look at that. Graham, lead us off here. What are we looking at?
That's great. So we're looking at benitoite. So gems, and this is actually something I don't really know that well. We've talked about minerals and how minerals can make up rocks, and gems are a special type of mineral that have really clear colors or very colorless, and have a special value to them. So benitoite is our state gem. It's this vibrant blue color and these sort of neat triangular looking crystals, although it's not always triangular, but it's often like that. And Gavin, where does benitoite get its name from?
Well, Graham, this kind of gives me a little bit of California pride because benitoite was first found only about 100 years ago in 1907 in San Benito, California. And it forms in this really specific area, and it kind of bridges the gap between the state rock and the state gem. So can you talk to me a little bit about that?
Absolutely, yeah. So the spot in San Benito County where benitoite was first discovered, and it was actually thought to be a different mineral until a a mineralogist at UC Berkeley confirmed that it was a new mineral and helped coin the term bonitoite. So it was found in a serpentinite dome near New Idria in San Benito County. And so bonitoite actually forms in serpentinite and blue schist rocks, and it forms in these hydrothermal veins in there. And so this is going to be a current throughout today's Rockin Pop-Up, is hydrothermal, and that seems to be a really important geologic process here in California. So Gavin, how are we forming these in these hydrothermal veins?
Well, Graham, so we've talked so much about what happens when you pump really hot water into rocks. And you're able to pull all kinds of elements out of those rocks, and you can make really, really interesting minerals out of it. I'm sure the audience can remember back to our Rockin Pop-Up about chemical sedimentary rocks. And this is the same sort of thing. Bonitoite is a chemical sedimentary rock. It's found in veins, which are filled cracks of chemical sedimentary rocks that form out of hydrothermal fluids. And so bonitoite is no different. So what happens is that hydrothermal fluid interacts with the serpentinite dome, and it pulls out specific elements, these interesting elements, and the ones that form bonitoite are barium, titanium, and silicon. And so the barium and titanium are what give the bonitoite its really different sort of look, its different crystal habit, and a couple of other interesting characteristics. And so, Graham, can you take me through some of the interesting characteristics of bonitoite and maybe explain to the audience what we're looking at with this picture in the top right?
Yeah, absolutely. So one of the cool things about bonitoite is that, and a thing that makes it a great gem mineral is just how clear it is. So the way all those elements and atoms are stacked together, it lets a lot of light through, but it also turns it that bright blue color. It's pulling out all the reds and everything other than the blue light. But then something really cool happens with bonitoite when you shine a UV light on it. It's something we call fluorescence. And so what happens is when you shine that light on there, the UV light, which we can't see with our eyes, starts exciting atoms in the bonitoite, or it excites parts of that molecular structure, and it causes it to send light back out of it at wavelengths that we can see. So it takes on this really kind of ghostly, like blue hue. And Gavin, this isn't the first time we've talked about fluorescence, isn't that right?
It's not, but it's the first time in a long time, Graham. And I hope that someone watching this video had visited our stall at the Santa Cruz Museum back in 2018 on Halloween, because we had a bunch of these fluorescent minerals out and we were shining UV lights on them and showing all these different kinds of fluorescence. So this one's a nice throwback for the gents.
Absolutely. And it's fun because often an element that's really good at fluorescing is one of our favorite elements that we really actively study, and that's the element uranium, which is a very popular it makes a lot of minerals fluoresce. So yeah, bonitoite is, I find, very, very lovely, both under visible light and UV light.
Awesome, Graham. And so, okay, we can be really, really proud of our bonitoite because it was found right in our backyard. But is it found anywhere else in the world, Graham?
Great question, Gavin. Bonitoite is super rare. It's only found in a couple other places on Earth. So it's found, of course, in California. There's been a few samples found in Montana, and then a few samples found in Japan and New South Wales, Australia. So bonitoite is almost exclusively Californian with just a few exceptions.
That's right. And definitely the most iconic, the blues and the most iconic and the first was found in California. So
That's right.
But everybody's probably on at the edge of their seats right now because we haven't covered the one and only gold. Can't talk about the California state symbols without talking about gold. So Graham, we've got some interesting looking diagrams here. Can you talk to me about how gold forms and why it might be in California?
Yeah, Gavin, it would be my pleasure. So gold is forming So gold is very rare at the surface of the earth. No one out there needed me to tell them that, right? We all know that gold is very rare and hard to come by. And the best way to get gold on earth is actually if we were to go deep underground. And that isn't to say that there's, piles and piles of gold down in the Earth's mantle, but in the Earth's mantle, there's lots of hot rocks that have a decent amount of gold in them. And what happens is when those mantle rocks start forming molten rock and start, making magma in the Earth's crust, what happens is they start bringing this rich, fertile mantle or this rich, molten rock up closer to the surface. And once it gets close enough to the surface, it starts interacting with water, and that gold goes into the water. And so that water is sort of mining this gold out of this hot molten rock. And then what happens to that water, Gavin?
Well, Graham, that water's got nowhere to go. It's under a lot of pressure, and so it starts breaking its way into the rocks that are above it. And so I'll just take everyone through these diagrams really quick. As Graham had mentioned, we have this hot molten rock down below the surface. It's interacting with waters. The waters are pulling out a bunch of elements, and they're cracking their way up into the surface. But these are really, really far below the earth. So these waters aren't actually making their way, in most cases, all the way up to the surface. And so they solidify as veins, just like we were talking about with that benitoite is formed in. And so if you were to find gold in its natural form, it would be in veins that look like this one where my cursor is. And you often find gold in association with quartz because the quartz is also being deposited out of that water. The quartz is much more abundant in that water and is much more normally deposited, but in these nice few cases, you get gold in those veins too. Graham, did all of the 49ers just dig into veins like this? Is that how they were finding the gold?
No, Gavin, and this is such a good question because mining gold out of rock is a really hard thing to do. It forms in these, big chunky granites that are really hard to break into. And, there's not a lot of it in these veins. They tend to be kind of small and isolated little things. And so the best way to find gold is to let nature do the mining for you. And so if you've got these big granite mountains that are weathering away, they're getting beaten up by the rain and the wind and the snow, and rivers are running down them, that helps to actually break these chunks of gold out of the rock. And now gold is really, really resilient. It's hard to break it down because what you end up doing is because it's so soft, you can just kind of squeeze it and reshape it. And it also doesn't really react with with water or any other elements at the surface of the earth. So it doesn't get chemically weathered or broken down by the elements in any way. And so what happens is this gold's getting mined out of these mountains, and then it tumbles down in rivers and gets concentrated in river deposits and in rivers themselves. And so the 49ers were taking advantage of these big river deposits called placer deposits and the rivers themselves by panning for gold out of those. And so the best way to mine gold is to not even mine it at all, but let nature do the work and then take advantage of those places where nature has concentrated gold for you.
Well put, Graham. I wouldn't want to break through all these rocks if I didn't have to anyway. So thank you to the water on the surface of the earth for doing it for us. And you had mentioned something. You said that gold is often found in big granite mountains maybe. And so that kind of segues into our next slide. Where do you think most of the gold is situated in California? Is it all over, or is it in just some specific places?
Well, I'm trying to think of where in California we've got a massive, I might even say a batholith of huge granite rock that could be a great source for gold. Where do you think it could be, Gavin?
Oh, well, Graham, I think that we've talked about this place all the time. The Sierra Nevada batholith, of course. And so the Sierras are a hotspot for gold. That's sort of the iconic area where gold is found in California, but not the only area. You actually do see a lot of gold found in the northern volcanics regions because there's a lot of volcanic activity going on up there, so really good places for gold. And then, Southern California's got to get in on the party as well, And so scattered about, you have all of these gold deposits because you have all of these scattered volcanics and granite bodies. So
Awesome. Very
yeah.
cool. And then,
So,
and so
Graham,
then,
sorry.
sorry, Gavin, go ahead. No, please, after you.
Well, I was just going to ask you a question, Graham. California's got to be special in terms of gold, but gold is actually found all over the place. And if we see on this map, it kind of looks like it follows some of the same patterns as serpentinite. And so can you take us through what's going on there?
Yeah, absolutely. So you made a very good point, Gavin. It's not just where big granite, magma bodies form. It's any place you've really got active volcanoes, because those help to sort of bring hot magma up to the surface, and then any waters interacting with those magmas will help pick up the gold. So that's why we often see gold deposits in any place where we've got active volcanism going on. But another thing that's really that really helps gold form is, remember early on I talked about these rich, these fertile magmas, these magmas with lots of uncommon elements and materials in them that are sort of stored and stewed deep in our mantle. And we find those at the surface at these places called hot spots, where we've got deep upwelling from the mantle. And so those are special places where we can kind of get some extra good gold concentrated up at the surface.
Interesting. Okay. Well, Graham, we had a great lineup of California state symbols. All those really cool rocks, minerals, gems. But I actually have some ideas of what I would make the state rocks, minerals, and gems if I had a choice. What do you say we go through our choices?
That sounds great, G.
Okay. So I'll run through mine first. I don't know if anybody in the audience has ever seen a rock that looks like this one, but this is called the Morgan Hill Poppy Jasper. It is, to me, just the most outrageously cool rock I've ever seen. And it's right here in a beautiful place in the Santa Cruz Mountains called Morgan Hill. It's sort of like a local legend there. Everybody knows it's there, but they don't know where it is. It's kind of like a secret to the locals, you know what I mean? But it is just these beautiful little poppy jaspers. They call them poppy jaspers because they look like the poppy flower. So I just think this is very apropos. And if there was going to be a state rock of California, I would make it the Morgan Hill Poppy Jasper. What about you, Graham?
I had to go with the Sierran granite. For me, I can't think of anything more Californian than the great Sierra Nevada mountains, the rock of Yosemite Valley, these large, coarse, resilient granites that are, that have been stored underground for the longest time and now make this, stark and beautiful mountain range.
It's the classic. I agree with you. That's a really good one. What about your state mineral, Graham? This is a less straightforward question.
Yeah, so this one, I went with something that isn't as, iconically California, but bear with me. So California is really characterized in terms of its geology by all the faulting going on here. There's lots of really active faults. Earthquakes are a major hazard that Californians have dealt with throughout the history of California. And so, a big thing or a big area of study is trying to understand the mineralogy of faults. Why do faults behave the way they do? What helps them slip? What keeps them from slipping? And one mineral that has been hypothesized to be really important for sort of regulating how the San Andreas Fault moves is talc. Talc is this smooth, slippery mineral. It's what talcum powder is made out of. It's got kind of this soapy feeling when you rub it in your hands. But that's been a key rock that some folks have thought and have suggested is really important for regulating how the San Andreas Fault moves. So that's my choice for the state mineral. What about you, Gavin? This looks like a familiar mineral.
Yes. Graham, I just have to say, talc is such a cool choice. That was a very clever play there. I really liked that.
Thank you, Gavin.
But I went with something a little bit more, with a little bit less thought, I would say, the mineral quartz. And this is, everybody is probably sitting at home saying, oh man, quartz, Gavin, you couldn't have come up with a better option than that. It's just so normal and not rare at all, and kind of drab. But I would argue that there's nothing more iconically California than quartz, because where do you find all of your gold deposits? In quartz veins. And what are all the beaches made out of? But mostly the mineral quartz. And what about your precious Sierran granite, Graham? Well, there's a lot of quartz in there as well. So I think that quartz would be a good state mineral if you had to ask me.
You know, Gavin, how dare you say that my mineral had more thought in it? I think your call of quartz is certainly the more clever of the two. It really is. There's quartz all over the place here, and all the things we love about California, at least geologically speaking, wouldn't be that way without all of that quartz.
Well, I'm glad you liked it, Graham. And let's kind of go over to the gem side. And again, this isn't the gents' bread and butter. We're not gemologists, but we've got some ideas for state gems. Graham, what'd you put up here?
So I picked a mineral called glauconite, and you don't find it. You don't find it everywhere here in California, but glauconite is what happens when you take very kind of deep sea sediments, and you put them under heat and pressure. And what's really important about being in those deep sea sediments is it has to have a lot of bits of critters in them. So I'm talking like little microbes, and the little microbes poop is the protolith of glauconite. So you get all these this ocean muck, and you heat it up and you bake it underground. And that forms this sort of bright green, almost gemmy looking mineral called glauconite. And you don't see it all over the place in California. You see it in a handful of places. You can actually find some of it in the Parissima sandstone. And what I think makes it really Californian is California is a place where the ocean is being incorporated into rocks, and those rocks are being thrust up onto land. And I think glauconite really captures that geologic history of California.
Good one, G.
Thanks,
Really
G. And so you've got a similarly greenish looking mineral there. Tell us what you've got for the state gem.
That's right, Graham. So I'm going to round us out with another mineral that is aptly named for a place in California. This is Mariposite. It's named for Mariposa, California, where it was first found and characterized. And it's almost gem quality. That people find it in gem quality specimens, but it's really interesting to me because it's actually a mica. So we've talked about the minerals biotite and phlogopite. These are these like really sheet-like minerals, and they're usually very dark, but this one is actually really bright green. And so I just thought, another California characterized mineral, got to pick that one.
Love it. What a great choice. And such a beautiful mineral. I love that color of it.
I think so too. Well, Graham, I think we've done it. This was a pretty fun one, I have to say. California has just so many cool specimens. It's like kind of a geologist playground in a way.
Absolutely. Lots of great geology, lots of cool minerals forming here. It's a lot of fun to look into these California rocks.
I agree, Graham. Okay, I'm going to stop sharing here. We can turn it back over to Marisa.
Cool. Thanks so much for that, guys. And we had some fun in the comments talking about serpentine soils. And I'm curious if you all know what the state rocks are for your home states, state rock, gemstone, or mineral.
You go first, Graham.
This is very embarrassing. I don't. I need to look them up.
What would it be? Do you have a choice, Graham? I'm sure you know a lot about the rocks of Wisconsin.
I know a little bit about the rocks of Wisconsin. Wisconsin is a lot of limestone. So Wisconsin, for a lot of the last several hundred million years, when we had much warmer climates, so no polar ice caps and much higher ocean levels, Wisconsin was underwater for a long time. And so there's lots of deep limestone deposits. And then in the last couple million years, Wisconsin was on and off covered by a huge ice sheet. And that ice sheet ground its way down through the rock and beveled off all of the material that had collected on there. And so Wisconsin, most of the rock across the state, or at least the part of the state that I'm from, is these limestones from almost 500 million years ago.
That's a
So
long time.
it's a long time. And these limestones have been through it all. So they are looking pretty haggard at this point. But then there's awesome glacial geology all across the state. And I know Gavin can relate to that, having grown up on Long Island.
That's right. Long Island is just a big pile of sand that the glacier left behind 40,000 years ago. So your state is 500 million years old. My little area in the state in Long Island is only 40,000 years old, so pretty young. I actually also have the embarrassing fact that I don't know the state rock of New York. I know the state fossil of New York is Eurypterids, which is really, really cool. It's like a little crab-looking thing. But the state rock of New York escapes me. I have an idea, but I don't want to say it because I'm pretty sure it's wrong. But
yeah, it's not like I'm not really easily finding it. It looks like garnet is the state gemstone of New York.
That makes sense. I've been to some really, really amazing garnet mines upstate New York because New York, while Long Island's 40,000 years old, New York, the rocks in New York are really old. They're basically the bottom of an old mountain range. And so they're all metamorphic rocks and stuff. And there are these amazing garnets. And I've seen garnets that are the size of your head in these garnet mines. They're really interesting. So,
wow.
But I don't know the state rock, though.
But you know what? I don't know if y'all have one because it's not popping up. But Wisconsin, we had some help from Mary.
Awesome.
The state rock of Wisconsin is the red granite. Does that sound right to you?
That sounds right. I actually cheated and looked it up. Well, Gavin was regaling us with the beautiful garnets of New York. And then I also, while I was breaking the rules, I looked up the state mineral, and I don't know if someone's chimed in with it yet or not, but I'm a big fan of the state mineral. It's galena, which is a lead sulfide. And for those of you who have kept up with a lot of these, y'all know that Gavin and I have spent a lot of time measuring lead, measuring the isotopes of lead. And so galenas have been really important for understanding the history of the evolution of lead compositions on Earth because they sort of lock in the lead at the different times they formed throughout Earth history. So that's actually a really cool one that I had known at one point, but forgot. So, yeah, we gotta be proud of our.
You'll remember some California state symbols now.
Yeah.
This is your new home base. And also we do have a question in the comments really quickly.
Awesome.
Just curious if you have all of these favorite rocks, gems, and minerals that you've shared, and someone is curious if you have any of them in your own personal collections.
Oh, I have to say, I actually have a piece of the Morgan Hill Poppy Jasper that was given to me by my girlfriend's grandparents, who are collectors, and they found a piece and gave it to me, and it just blew my mind to have a piece. And then, of course, the Sierran granites. Whenever you're out there and you're not on state or national park land, gotta grab a piece.
What about you, Graham?
Yes, I do have a piece of Sierran granite, and I do have a piece of talc from a really weird sort of serpentinized, but not serpentinite, rock that I used to study out in Maine that has some talc in it. I don't have a good glauconite specimen though.
Mm-hmm.
Well, yeah, that Poppy Jasper, that is so interesting because Morgan Hill is so close to here, and so I'm really happy to learn about that one. That was a really interesting little tidbit for me, and then also just bonitoite. I think for a lot of us here in Santa Cruz, we maybe have known about that one, and San Benito County, it's not too far. So really exciting things, and like you guys were saying also about serpentinite, it's one of those things where it's just all over the place here, and how special is that it's so readily available and easy to look at and discover here in California when that's not the case in most parts of the world. Do you guys have any tips for where to notice serpentinite and what to look for?
Yeah, serpentinite, I think Graham can sort of give a place better, because I just often find it whenever I'll be like walking on campus up at UCSC, and you walk down by the meadow on the you walk down by the meadow, and there are just like big chunks, and it's just really, oftentimes you don't see the fibrous asbestiform long crystals, but there really aren't too many other rocks that jump out to you as green like that. So you can find it up in the Santa Cruz Mountains often, and down in certain places in town. So it's really kind of all over the place. Graham, do you have any specifics on that?
Yeah, I know that there's, so the foundations of the Golden Gate Bridge are built on serpentinite, if I'm not mistaken. So if you head up to San Francisco, you can put your eyes on some serpentinite. And there's a lot of it sort of around the Bay Area, where there's a lot of these uplifted mountains that have sort of rich serpentinized roots to them. But no doubt about it, there is definitely serpentinite up in the Santa Cruz Mountains. We can find it on the slopes of the hills here, and it tumbles down the rivers through here. And so it's kind of cool because you don't have to go very far along the California coast to find it.
Yeah, and it has that kind of gray, green, blue sort of soil too when it's really broken down. So sometimes I notice just these patches along road cuts or driving around where it's just like that looks a lot more gray than the surrounding dirt because it erodes so well. So that's a fun one to look for. So I hope everyone tunes their eyes to be looking for serpentinite. And do you guys want to give us a little sneak peek about what we're going to be talking about next week?
Yeah. So Gavin and I have spent a lot of time talking about rocks, and we're going to shift our view a little bit for this next week and talk about coastal landscapes. So getting a feel for some of the way that the ocean and the interaction of the oceans and tectonics have shaped the lands around California and other places on the coast.
Wow, that is going to be a good one. I'm so excited for that. So thanks so much for this, and thanks to everyone for joining us, and we'll see you next week.